Welcome back, mathematicians. In this video, we are going to look at the horizontal compression or stretch transformation. So in general, we would write this horizontal stretch or compression transformation as y is equal to f of a times x, where the argument x has been replaced with a times x. Our first goal with this is actually to find the value of 1 over a, because that is the factor you will multiply to all x coordinates to get the graph of your function. And so I like to refer to the value of 1 over a to determine whether it represents a compression or a stretch. If 1 over a is greater than 1, then we have a horizontal stretch. If, however, 1 over a is less than 1 but greater than 0, then what we have is a horizontal compression. I like to think of it like this because it more or less lines up with our vertical stretch and compression logic. But no matter what, everyone has to find 1 over a so you can multiply the x coordinates. Let's look at our first example, which is f of x is equal to the square root of 1/2 times x. So the first step will be to find the parent function, and the parent function is the square root of x. We are now going to graph that parent function. I'll make a t-table of values where we'll plot 0, 0, 1, 1, and then 4, 2. This results in half of a parabola opening to the right. And my goal now is to transform it based on what we have here in our function, which is 1/2 times x under the radical. Because it's under the radical, that's how I know it's horizontal. So my first step is to find 1 over a. Well, if a is equal to 1/2, then what I have for 1 over a is 1 over 1/2. Simplifying that, it's equal to 2. That means that 1/2 actually represents a horizontal stretch by a factor of 2. And so what we'll do is multiply all of my x coordinates by 2 to get my new x coordinates, which means my new ordered pairs will be 0, 0, 2, 1, and 8, 2. So that's the graph of the square root of x that's been horizontally stretched by a factor of 2, even though the coefficient of x is 1/2. So again, the first step is to find 1 over a. Our next function is g of x is equal to the square root of 2 times x. So again, I'm going to look at the parent function, which is the square root of x, and I'm actually creating the exact same t-table as the first example of 0, 0, 1, 1, and 4, 2. Now I identify the transformation. Because that coefficient of 2 is under the radical, because that coefficient of 2 is under the radical, that's how I know that this will be a horizontal transformation. Because it's 2 times x, I know it's got to be a compression or a stretch. But my first goal is to find 1 over a. Well, if a is equal to 2, then 1 over a is equal to 1/2. This tells me then, because that 1/2 value is between 0 and 1, this represents a horizontal compression. By a factor of 1/2, which means I'm going to multiply all of my x coordinates by that factor of 1/2 to get my new graph. At no time does this horizontal stretch or compression impact the y coordinates, just the x coordinates. I will then have 0, 0, 1/2, 1, and then 2, 2. So that would be the graph of the square root of x horizontally compressed by a factor of 1/2. All right, guys, good luck.